our topic is elasticity of demand. Okay? Elasticity of demand. But I want to be very honest with you. Professors get a little lazy, and it's technically the price elasticity of demand. So you may see reference in a homework question or a quiz or some other application where it says the price elasticity of demand, but that's a lot of words, and professors in class kind of just end up calling it elasticity of demand. But before we do that, let's talk about what we mean by an elasticity, because price elasticity of demand is not the only elasticity that there is. There's a few of them. Elasticity is simply capturing, it's actually measuring, so it's going to be something quantitative, the impact on X, whatever X is, from a change in some variable Y. So when we talk about an elasticity, we're simply measuring the impact on some variable X that comes from a change in Y. So in other words, we're asking the question, when Y changes, how does that impact X? But we're literally measuring it. So we're not just saying it goes up or it goes down. We're going to quantify it. So we're going to quantify the impact. So that means when we're looking at elasticities, we have to do a little math, because this is going to be a quantification, not just a qualitative relationship. So we're not saying, hey, it makes X go up or it makes X goes down. We're going to say it makes X go up by 10%, by 15%, by 20%. So we're going to use some numbers, okay? But I don't think you're going to find it too very difficult. The math is very simple. So let's start by talking about the elasticity of demand. And you're going to see that we abbreviate elasticity of demand as E sub D. So get in that habit, because elasticity of demand, trying to write that over and over and over again is just too much. So elasticity of demand is going to capture consumers' responsiveness to changes in price. So consumers' responsiveness to changes in price. So again, remember, an elasticity captures how does X get impacted when Y changes. Well, the thing that's changing is price, and we want to know when price changes, how does this affect, for example, the quantity demanded that they buy. So we're very simply asking, if price changes, how does this impact quantity demanded? So we have an X and we have a Y. Now, hopefully you're thinking, well, we have this thing called the law of demand. So let's remember the law of demand. And the law of demand says, if price goes up, then what? Quantity demanded goes which way? Goes down. And if price goes down, then quantity demanded goes up. And remember, the law of demand holds only when we're holding all else constant. So basically what we're doing is looking at this relationship. And we already understand a lot about this relationship. So clearly elasticity of demand is connected to the law of demand. But here's the thing. Law of demand is only a qualitative relationship. It's only a qualitative relationship. It doesn't tell us how much. It tells us if price goes up, then quantity will go down. But it doesn't tell us How much? And that's what we sometimes want to know. How much? How much will quantity change? So all we're doing, guys, and I want to urge you to realize that all we're doing is taking things that we already know and we already understand, because we already understand the law of demand, and we're adding some numbers to it. Plain and simple. There's nothing particularly difficult about this, okay? But think about why you might need this. Let's say you're working at a firm, and the firm is thinking about raising their price, and they come to you as the economist and they say, hey, we're thinking about a 10% increase in price, and we want to know how our sales will be impacted. Can you simply say to them, oh, if you raise your price, sales will fall, because that's what the law of demand says? Is that a good answer? Is that going to make your boss happy? No, because what he wants to know is, hey, if we raise our price by 10%, how much will sales fall? Will sales fall by 3%? Will they fall by 15%? Because that's going to have an implication on your revenues as your firm. So we need to have more tools in our toolkit than just the law of demand. The law of demand tells us the direction of the relationship, but it doesn't quantify anything. So now we need to quantify that. Does that make sense? All right. So a good example would be my husband. He owns a CPA firm. So my husband's a CPA, and he knows that he can raise his prices just a little bit because people are fairly loyal to their CPAs. They don't want to go change accountants all the time, just like people don't want to change doctors. So he knows he can raise his price a little bit every so often, and he's not going to lose a lot of business, because he knows that when we talk about consumers' responsiveness to price, he knows his consumers aren't that responsive to price. But what if people shop around and change accountants every year? If he raises his price, he might lose a lot of customers, and then he's not going to make as much money. So he needs to know, how price sensitive are his clients before he implements a price increase. So let's look at some scenarios. And then you'll see why we need to understand just how price sensitive our consumers are. So let's say we've got 3 scenarios. We're going to increase price by 10%. So we're going to increase price by 10%. Scenario 1, let's say we increase price by 10%, and as a result, quantity demanded falls by 3%. So that's scenario 1. Increase price by 10%, quantity demand falls by 3%. But let's say quantity 2 is that we increase price by 10%, but quantity demanded falls by 12%. And scenario 3, we increase price by 10%, and quantity demanded falls by 10%. So I've got 3 scenarios here, and I'm raising the price by 10% each time. Now, guys, take a look at those 3 scenarios. Does the law of demand hold for all 3? Does the law of demand hold for all 3? What's the answer? Yeah, right? So we see that the law of demand holds for all 3. Right? Because we see that we increase price and quantity demanded falls. So law of demand doesn't really help me sort out between these 3 different scenarios. Now, I want to look at the impact on revenue. I want to look at the impact on revenue from these 3 very different scenarios that all illustrate the law of demand. So that requires me to understand what revenue is. Revenue is simply the dollar value of our sales. So revenues are the dollar values of our sales. I've sold 100 burgers and I sold them at $5 and I have revenue. So revenue is calculated as P times Q. It's calculated as P times Q. So I have 100 burgers, $5 a burger. What's my revenue, everyone? $500, right? $500. Guys, is revenue the same as profit? Is revenue the same as profit? No, because what have I not subtracted? Expenses, right? My costs, my expenses. So revenue is simply how much am I bringing in. It is not the same thing as profit. So you should probably make a note about that because we're going to be using both profit equations and revenue equations. But let's think about the impact on revenue from these three scenarios. So let's look at the first one. Price goes up by 10% and sales fall by 3%. What does that suggest to you about the revenues? Are revenues going to go up or are they going to go down here? You're making 10% more from every sale, but you're losing 3% of your sales. So what's going to happen to our revenues here, guys? Everybody, what's going to happen to our revenues? You should be able to intuitively figure this out, right? If I make 10% more money from every sale and I only lose 3% of my sales, what's happening to my revenues? My revenues are going up. Good. My revenues go up, right? But what about scenario B? Price goes up by 10%, but here consumers are fairly responsive, right? Look, they're cutting back by 12%. So I'm making 10% more from each sale, but I'm losing 12% of my total sales. What does that suggest to you is going to happen to revenues? My revenues are going to go down, exactly. But do you see that both A and B have the law of demand at work? Both of them are consistent with the law of demand. But one results in more revenue and one results in less revenue. What about case 3? We raise our price by 10% and sales fall by exactly 10%. What do you think is going to happen to my revenues? There's going to be no change in revenues. So my revenues don't change. So what do you think is the bottom line here? What am I trying to illustrate for you? Is law of demand enough for making decisions? Is law of demand enough to guide you? If your boss says, we want to raise our price by 10%, can you tell him what the law of demand predicts? Would that be enough information? Oh, you're going to raise your price by 10%? Sales are going to fall. That's not what he wants to know. He wants to know, are sales going to fall by 3% or are sales going to fall by 12%? So you need to know, if you're in any kind of business, you need to know how price sensitive your consumers are. That is vital information. And that's going to be influenced by a number of things. We're going to talk about what might influence this, but what's one thing that you think might really influence this? Let's think about the fast food hamburger market. Is it highly competitive, guys? The fast food hamburger market? Seem highly competitive to you? If McDonald's wakes up one day and says, hey, we want to have a 30% increase in the price of our burgers, what's something that they should be thinking about? Are people that loyal to McDonald's, or what might they buy instead? Burger King or Wendy's, or maybe they go get something altogether different like Arby's. So you need to know the kind of environment that you're operating in before you start changing price. So this is clearly going to be a function of the amount of competition, for example. So if McDonald's increases their price, there are very close substitutes. So they better do a study to get a sense of just how price sensitive their consumers are. And I guarantee you folks, McDonald's has a lot of economists that do this kind of research. And before they make any changes in price, they have some really good information about what the results are going to be. All right, so let's take a look then at how we calculate elasticity. Everybody with me? So when we calculate elasticity, it's a simple equation. Elasticity demand is going to be the percent change in quantity demanded of some good, let's call it X, percent change in quantity demanded of X over percent change in price of X. So that's your basic equation. Now, that's in the easiest form, and we're going to learn what we do when all we have is raw data, but let's wait on that for a moment. Now, guys, take a look at this equation. Based on what you know about the law of demand, is this going to be a positive number, a negative number, or is it going to flip-flop? Based on what you know about the law of demand, what sign will this expression have? It's going to flip-flop? You agree with that? No? You think it's going to be what? You think it's going to be negative? All right. I agree with her. It's going to be negative. Think about what we know, guys, and this is what I want you to remember. You already understand the basics of this. Now think about what we have learned from the law of demand. If price goes up, what happens to quantity demanded? It goes which way? Down, right? Or what if price goes down? If price goes down, quantity does what? If we lower price, quantity demanded goes which way? Goes up, right? So remember, the law of demand is helpful here. While law of demand doesn't tell us if we should raise our price or not, we do need to remember what we know from law of demand. So remember, the law of demand tells us that there is a negative relationship between price and quantity. So the law of demand tells us that there's a negative relationship between P and Q. If one goes up, the other goes down. So what does that tell me, guys? Elasticity demand is going to be what kind of number? It's going to be a negative number. So the calculation for elasticity demand gives us a negative number. But just to make things confusing, we take the absolute value and everyone understands what that means, right? So you've seen absolute value. It's indicated by the two vertical lines. So what does it mean to take an absolute value? Everyone remember, it means to drop the negative sign, which means we're going to express as a positive number. But you need to remember it's actually a negative number, because there will be times when we work backwards that you have to remember it's negative. So let's say that a study reveals that the elasticity demand for good X is 2. Keep it simple. A study reveals that the elasticity demand for good X is 2. Well, what does that tell us? That tells us elasticity demand equals 2. But what do I have to put back in if I'm working backwards? I have to put back in the negative sign. So it's really a -2. So if I look at the equation, percent change in Q over percent change in P, that means if we change price by 1%, then what happens to quantity? If I increase price by 1%, then quantity does what? Which way does it go? It falls by how much? Falls by how much, guys? 2%. Good. So if elasticity demand is 2, which is really a -2, everybody with me? Then that tells me that for every 1% change in price, quantity changes by 2%. What if we make a 2% change in price? And we still think elasticity demand is going to be 2. What does that tell us about quantity demanded? It's going to fall by what? It's going to fall by 4%, right? Because I have to end up with a -2 elasticity demand. Everybody with me there? So guys, do you see this is easy math? Nobody should be struggling with this. Keep it simple. This is easy math. Okay, everybody with me so far? All right, what if instead we're going to lower our price? What if we decrease our price by 3%? Again, we're still assuming that elasticity demand is 2, and it can change. So if I lower price by 3%, elasticity demand tells us that quantity will do what? Quantity will go which way, up or down? Increase by how much? 6%. Good. You with me? So, any questions at this point, guys? Easy to work with. All right. So let's add on a little bit. So this is the easiest type of equation manipulation we're going to work with. It's going to be a little bit harder mathematically, but just a hair. But let's stick with this for right now. So let's think about what these numbers really tell us. Let's look at football ticket prices. So let's say that Texas A&M, home of the fantastic Aggies, we love them. They're great. They have good fans. But Texas A&M decides, oh, is that a sneer I'm seeing in the back row here? Don't make me kick you out. I have 3 degrees from there. All right, Texas A&M University, home of the Aggies, decides to increase the price of their football tickets by 15%. So Texas A&M decides to increase the price of their football tickets by 15%, and as a result, sales fall, which, right, makes sense. The law of demand says you raise price, sales are going to fall, but we want to know by how much. So let's say sales fall by 5%. Then, down the road, we've got those T-sippers from the University of Texas, boo hiss, but they like to copy us, so they say, oh, well, if the Aggies are doing it, we're going to do the same thing. So University of Texas decides to increase the price of their football tickets also by 15%, but they get a very different result. As a result, sales fall by 20%. All right. So you're going to need your calculator that I asked everyone to bring. So get out your calculator. And not your phone, please. So here's what I want you to do? I want you to, number one, calculate elasticity of demand for each. Number two, I want you to determine the impact on revenues. And then number three, after you've done that for both Texas A&M and University of Texas, I want you to figure out the implication of elasticity demand being larger or smaller. In other words, what does this mean? All right. So take a second and work through that, please. And then we'll compare. And I want to see everyone working, but if you need help, raise your hand and I'll come help you. And guys, can I also suggest that you always get in the habit of writing the equation out? And then plugging in what you know. So I'll give you another minute or so to finish up. All right, 30 seconds, and we'll go through it together. All right, so let's take a look, guys. For Texas A&M, we said that price would go up by 15%. So that goes on the bottom, 15%. But ticket sales fall by 5%. So make sure you did not forget that negative sign. While we're going to take the absolute value here, when we work backwards, we've got to remember those negative signs, okay? So we've got negative 5% over 15%. But I can cancel the percent signs. So let's do that. Cancel our percent signs because that's like having a form of 100 over 100, which gives me negative 5 over 15. which is 1/3. And I'm going to be on a test putting everything in the format of decimals. So get in the habit of decimals, guys. So we have negative 0.33. But what do I have to do next? It's a negative number. Take the absolute value, which gives us an elasticity. So price elasticity demand is 0.33 for Texas A&M. All right. Let's figure out what it is for University of Texas. So they also increase their price by 10%. But in this case, sales fall by 20%. So again, you should have negative 20 on the top. We can cancel the percent signs, but guys, be very clear. I can only cancel them when they're on the top and the bottom. I can't just drop them if I'm working a different kind of problem and there's a percent sign there. So that gives me negative 20 over 15. And if you did it in decimal, rather in fraction, you would have negative what? 4/3, which is I think what? 1.33? All right. So negative 1.33. But again, remember, you've got to take the absolute value. When I do, I get absolute value being 1.33. So elasticity demand at University of Texas for this level of price change for tickets is much different than other than Texas A&M. All right, you with me? They have very different price responsivenesses. Everyone agree? Okay. Now let's figure out impact on revenue. So let's remind ourselves that revenue equals P times Q. All right, that's an equation you need to know. Now, if this is a little confusing for you, let me show you a way that you can kind of sketch it out and then make it more intuitive. We have price going up by going down. Let me fix that. We have price going up. Sorry, gosh. Price is going up by 15%. Everyone agree with that? But quantity here falls by what percent? Only 5%. So do you see how I use those little arrows to kind of sketch it out for myself? So we're making a lot more money from all the sales that we will have, but we're going to lose a few sales as a result, but only 5%. What's happening to revenues here, guys? In net of these two effects, revenue's doing what? Going up, right? So revenue is going up over here. But let's look at University of Texas. So revenue equals P times Q. And again, sometimes it's a good idea to sketch it out. So price is going up by 15%. But at University of Texas, what's happening to quantity? It's going down by 20%. All right. So you're making more money from all your sales, but you're losing a lot of sales, right? What's the net effect? Is revenue going to go up or is revenue going to go down here? Everyone agree? Revenue is going to go down here. Now again, guys, do both of these scenarios adhere to the law of demand? Do both scenarios adhere to the law of demand? Yeah, at both universities, price went up and quantity went down. And that's why law of demand doesn't help us answer important questions about should we change price. I need more information. I need to know just how price sensitive consumers are. So guys, which university has the more price sensitive consumers? Who has the more price sensitive consumers? University of Texas, right? They're not as loyal to their university as those fans from Texas A&M, right? Because they're losing a lot more sales when they raise price. So then what can we conclude? The third thing I asked you to think about is what's the implication of a smaller or larger elasticity? So what can we say? When elasticity of demand is larger, what does that tell us? Consumers are what? Consumers are Are they more price sensitive or less price sensitive? Everybody, more price sensitive or less price sensitive? They're going to be more price sensitive. And when elasticity of demand is smaller, the smaller the number, then consumers are less price sensitive. Everybody with me there? Does that make sense? So now we understand the basics of elasticity of demand, and we understand why it matters, why we need to know this, why law of demand is not enough to help us make good decisions in a business environment. All right, so let's add on just a little bit. So when we calculate our elasticity, folks, let's think of it as a spectrum. So let's look at our absolute value of our price elasticity demand. And what we're going to see is that the smallest this number can be is 0. What would it mean if elasticity demand is 0? It means that nobody's responding to the price change, right? So maybe University of Texas raises its price and nobody stops buying their tickets. Or at Texas A&M, we raise the price and no student or fan stops getting a ticket, right? That would be 0. So it is possible to have elasticity demand of 0. Wouldn't you love to be a business with an elasticity demand of 0? That means you can raise your price and nobody stops coming to you. Probably not that realistic, right? The biggest it can be is infinity. We're going to talk about the case of infinity later. But basically, once we take the absolute value of elasticity demand, it goes between 0, no response at all. So 0, no response to a price change. And it can be as big as infinity, meaning that there's a complete response to a price change. But most of the time we're at smaller numbers. We generally don't do a study and find a 200 elasticity demand. It might be 0.7, it might be 1.8. It's going to be a smaller number. Now we divide here at 1. We divide here at 1. The reason we divide at 1 is this. If elasticity of demand equals 1, then we know that there's a very specific property. So if elasticity of demand equals 1, there's a very specific property. And that is, think about it. Let's write our equation out. Percent change in quantity over percent change in price. If that's equal to 1, then what can we with certainty conclude? What do we know? What do we know about the numerator versus the denominator? They have to be the same, right? So what that tells us is that whatever the change in price will cause an equal, but of course opposite direction, percent change in quantity. So if you increase by 5%, this decreases by 5%. Right? And if that's the case, guys, if we have an equal but opposite reaction, what does that tell us about revenues? If one goes up and the other goes down of the same amount, what happens to revenues? They don't change. Good. So revenues do not change. You with me here? So that elasticity of demand equal to 1 has a unique property. And that makes it an interesting place to divide. So we divided at 1. Anything in this region, 0 to 1, we call inelastic. So 0 to 1 is the inelastic region. And by inelastic, we're saying that we are less price sensitive. Between 1 and infinity, we call this the elastic region, meaning we are more price sensitive. So less than 1, inelastic, not that price sensitive. Greater than 1, elastic, we are sensitive, are price sensitive, we are responding. And then at 1, when it's equal to 1, we call that unitary elastic. Unitary elastic. So I know that is a lot. So make sure you understand that if elasticity demand is less than 1, it's inelastic. We call it inelastic demand. If elasticity demand is equal to 1, we call it unitary elastic. If elasticity demand is greater than 1, we call it elastic. And then, of course, make sure that you understand that we divide at elasticity equal 1 because it has a special property. And we explained that right there. All right. Everybody with me? Does that make sense? Okay. So far, so good? All right. So we have one more thing to add on. So let's do one more problem. Everyone have this down? All right. So in the problems that I just gave you for Texas A&M and University of Texas football tickets, I gave you the percentages, right? So what if you don't have data expressed as percentages, right? So I said, hey, Texas A&M raises the price of their football tickets by 15% and sales fell by 5%. But you may not always have that kind of data. So let's say that, let's pick another university, University of Alabama increases its football ticket prices from $30 to $40. And as a result, sales fall from, let's say, 20,000 tickets to 18,000. I'm sure their stadium is far bigger than that, so easy numbers though. And we want to do the same thing. We want to calculate elasticity demand. Well, still the same equation. So here, elasticity demand equals percent change in quantity demanded over percent change in price. But here I have to calculate percent changes. So I need to calculate a percent change. And I want to show you that there's an easy equation that you can use. We're going to use what I call the new equation. And guys, it doesn't matter if we're doing economics or you're looking at the percent change in your salary or the percent change in your weight or anything. This is how you calculate a percent change. So a percent change in X, whatever X is, doesn't matter, is going to be the new level of X minus the old level of X divided by the old level of X multiplied by 100%. So this is the new equation right here. New minus old over old. That's why I call it the new equation. New minus old over old. If you do it new minus old over new, you've gotten it wrong. New minus old over old. New, N-O-O. So if you remember that, you won't get it wrong. So we need to use this equation to calculate percent change. So elasticity of demand, let's start with the numerator. What is our new quantity, everybody? Our new quantity is what? What's our new quantity in this problem? 18,000. So we've got 18,000 minus our old quantity, which was 20,000, right? All divided by our old quantity of 20,000 multiplied by 100%. So that's the numerator. That's going to give me percent change in quantity. Now I have to do the same thing on the denominator. What's our new price? What's our new price, everyone? 40. So our new price is 40 minus our old price of 30 over our old price of 30 multiplied by 100%. So I use the new equation to find the numerator and the new equation to find the denominator. All right, now I can clean this up. So let's clean this up a little bit. First thing I can do is cancel out the percentage signs because I have it on the top and the bottom. So on the top, it gives me negative 2,000 over 20,000. And on the denominator, it gives me 10 over 30. So everyone agree that this is 1 over 10 on the numerator, and it's 1/3 on the denominator, and you can use your calculator at this point. But this gives me what? Negative 3/10 or negative 0.30. Is that correct? Everyone agree? All right. But remember, elasticity of demand is a positive number when we take the absolute value. So here, elasticity of demand is 0.3. So guys, very quickly, in the last minute, what does this tell us about demand? Demand is what? Inelastic, right? It's less than 1, so they have inelastic demand. And last thing, what happens to revenues here? We raised price by quantity fell. What does that tell you? If you have inelastic demand, you raise price, people are not that responsive. Everyone agree that revenues here at University of Alabama are going to go up. All right. Okay, good. Make sure that you understand all of this, guys, and you'll have the opportunity to practice tonight.